Hello everybody. My next topic is why Fourier Transform is having continuous spectra. Now to start this, I must start before of this. In a way, I have to start it from Fourier not from Fourier Transform, I have to start it from Fourier Series. Now, you know this is a periodic sort of waveform, and this is the standard Fourier Series expression we get in our books. So, here this k is the component of frequency. Now, what does it actually means? It is actually meaning the magnitude of this waveform is dependent on different components of frequency. This is the part of DC component of frequency. These are two parts of real and imaginary frequency component, sine and cos. Now, the value of k when it is equal to 1, the value of k is equal to 1. When the value of k is equal to 1, the cos component and the sine component is becoming sine omega t and bk cos omega t. Now, this part is giving you the fundamental frequency component. In this way, when the value of k increases depending upon the even and odd values, it is giving you the magnitude of even and odd harmonics, and the whole thing actually constitutes the magnitude of the signal. Now, if we want to draw the frequency spectra of a continuous waveform, we can draw like this. Suppose this is the 0 DC component, 0 frequency. After that, we can get the first frequency component, which is known as fundamental frequency component. That means it will be omega, k omega, that means 1 omega. Next, after that, that part will be twice of omega. The next component will be 3 omega. These are the frequency, and this will be the magnitude. This will be the frequency and this will be the magnitude. Now, if we want to draw the magnitude spectra, what we will get? We will get that the magnitude component will have a sort of value which we know fundamental frequency component is having the highest magnitude. Then it will be having certain value depending upon the type of waveform, whether it is even or odd type of waveform. Depend upon that, you will find whether even harmonics or odd harmonics are there, whether they are present or not. But obviously their magnitude will be lesser than that of the fundamental frequency component. So, in this way, if we get the different magnitudes depending upon the frequency of the signal, they are separated. They are representing by lines. So, these are known as line spectra. This is not a continuous spectra. They are distant apart by omega amount of frequency. So, this is called line spectra or discrete spectra. So, as we have discussed in our previous lecture, that Fourier series is having a line spectra or a discrete spectra, and that is aperiodic in nature. So, this is aperiodic in nature and it is having a line spectra or a discrete spectra. Now, how it will be changing for same type of signal when the signal, we know when the signal is similar but is not periodic, that means it is aperiodic in nature, we perform Fourier transform, and at that time we are getting that the line, though the spectrum is aperiodic, but it is becoming continuous in nature. Now, how it is happening? Now, if we think of aperiodic waveform, if I take the same waveform, that means only this part will appear. No repetition will be, no repetition of the same waveform we can get. That is called aperiodic waveform. That is, it is not repeating itself with a certain pattern. That is aperiodic waveform. Now, by definition, aperiodic waveform is such where we can say that the time period of this periodic waveform was t. That means it will, the same thing is repeating after t time. By definition of aperiodic waveform, this that type of signal will said to be aperiodic, which is having the time period t tending to infinity. So that means the time period of if the time period of a signal is tending to infinity, that will be called a aperiodic signal. Okay. Now, what is going to happen then? We know that the frequency is inverse of time period. Now, for a aperiodic waveform, if t is tending to infinity, definitely omega will tending to 0. That means when we are thinking of a aperiodic waveform, what is going to happen? Now, this distance between the fundamental frequencies will tending towards 0, and this spectra will be in this fashion. It will be the difference between these two consecutive frequency will tending to 0, and this spectra will becoming continuous in nature. That is why the aperiodic spectra, the frequency spectra of a aperiodic signal is becoming continuous in nature. Thank you.